we're going to be doing loads of work with algebra tiles. These are examples of algebra tiles. You have small squares, you have rectangles, and you have large squares. Yours are all multicoloured on one side, so if you put them all to have their multicoloured side facing upwards. Now we're thinking about what each of these represent. This side here is the same length as this side here, and each of those sides we're saying is 1 unit long. 1, 1. So if each of those is 1 unit long, then the area inside here will be just 1 unit squared. So this box here represents 1. Now you'll notice that this rectangle is exactly the same height as that box, which means that the height of the rectangle is also 1. Now what's a little different about the length of this rectangle here is that we're saying it's unknown. We don't know. In fact, if we try and fit a few of these along here, it's not an exact amount that exactly fit. And this is an unknown. We've talked about this last time, a variable. It could be any length, and we're calling it x. Okay, so the area of this rectangle is going to be 1 multiplied by x, and hopefully remember that instead of writing 1x, we instead simply write x. So the area of this is 1, this represents x, and what about this? Well, if you have a look, this is exactly the same length, which means this is also x long, and if I was to rotate it 90 degrees, it's actually exactly x there as well. Now, so the area of this rectangle is x multiplied by x, x multiplied by x, or x multiplied by itself is x squared. Okay, so we've got this represents 1, x, and x squared. Now if you turn each of these over, you'll get this, a white version of the same. If you turn this one over, you get this. If you turn this one over, you get this. Now if you remember, this is worth 1, this is worth x, and this is worth x squared. Now each of the white ones are the inverse, the additive inverse, what you would need to put with this to make 0. So if this is 1, or you could also, and should really think of it as a positive 1, positive 1. What is the inverse of positive 1? It's negative 1. This is positive x, so this is negative x. This is positive x squared, so this is negative x squared. Okay? That is what each of the tiles represent.